is 7 into 6 into 5 into 4 into 3 into 2 plus 2 a composite number. So first write the given question as 7 into 6 into 5 into 4 into 3 into 2 plus, after the plus symbol only number 2 is there, so not to have any confusion in the next steps, write that 2 as 2 into 1. 2 into 1 anyway is 2 only, so no problem at all. Now before the plus symbol, here all the numbers are just multiplied, so this is considered as only one term. Then after the plus symbol, second term. So total in the given question 2 terms are there. Now from these 2 terms we need to pick the number which is common in both the terms. So let us check that once. In the first term as well as in the second term, number 2 is common. So let us take that number 2. Then if we take that number 2 outside or common, then what else are remaining here? 7, 6, 5, 4, 3 are remaining with the multiplication symbol. So write those all. 7 into 6 into 5 into 4 into 3. This 2 already we took common. So next one coming with a plus symbol. And here 2 into 1 is there. So 2 already we took common. Then remaining is 1. Into, let us multiply all these numbers. 7 into 6, 7 6 are 42, 42 into 5, 210, 210 into 4, 840, 840 into 3, that is 2520 plus 1 as usual. So here 2 into 2520 plus 1, 2521, which is equals to 2 into 2521. 2 1s are 2, 2 2s are 4, 2 5s are 10, 0 1 carry, 2 2s are 4 5. So 5042. And after finishing this answer, just write simply that it is a composite number. Then how do we know that it is a composite number or not? So composite number is nothing but the number which has more than 2 factors. For 5042, 1 is a factor. For 5042, that number itself is a factor. And the last digit is 2, so it will come in 2 tables. So 2 is also a factor. 1, 5042, 2. Not only these 3, still more factors will be there. But why I am considering only these 3 means these are very easy to find it out. Then, as I said already, composite number is nothing but the number which has more than 2 factors. So here 1, 2, 5042. 3, minimum 3 factors are there. So definitely this is a composite number. Is 8 into 7 into 6 into 5 into 4 into 3 plus 5 a composite number or not? Here also if you observe clearly, this is total one term and this is total second term. In the second term only one number 5 is there, so not to have any confusion, that 5 I am writing it as 5 into 1. Now in the first term as well as in the second term, if we observe, some number will be there common compulsory, that is. So let us check that one. Here 5 and 5. So 5 we can take common. So if we take out 5 common, then here we are remaining with 8, 7, 6, 4, 3 with multiplication. Write all those. 8 into 7 into 6 into 4 into 3 plus. And now from the second term, 5 already we took common, then remaining is 1. Write that 1 here. 5 into, let us multiply these all things. 8 into 7, 56, 56 into 6, 336, 336 into 4, 1344, 1344 into 3, 4032 plus 1. So 5 into 4032 plus 1, 4033. That if we do multiplication, we will get the answer as 20,165. Then how we will say that this is a composite number? This number will come in table, so 1 will become the factor, and this number will come in the same table, that is 20,165. And next here the last digit is 5, so then definitely this will come in 5 table. So here minimum 3 factors are there, then definitely this is a composite number. Next is 5 into 4 into 3 into 2 plus 3 into 2 a composite number. 5 into 4 into 3 into 2 plus 3 into 2. So if you observe this clearly, here one term and here one term. So total two terms are there. In these two terms, we need to check whether any numbers are common or not. 3 into 2, 3 into 2, both are common. So not to have any confusion in the next step, this 3 into 2 I am writing it as 3 into 2 into 1. Now if you observe again, 3 into 2, 3 into 2, 2 are common, right? So let us take out 3 into 2 common. So 3 into 2. Then here if you observe, 5 is extra, 4 is extra. So write those extra numbers, 5 into 4 plus. Then here after, second term also 3 into 2 already we took common, right? Then remaining is 1. So write that 1 here. So outside 3 into 2, 6 into 5 4s are 20 plus 1. If we simplify this further, 6 into 20 plus 1, 21. 21 6 are 126. Then how we can conclude that this 126 is a composite number? It will be having 1 as a factor, 126 also a factor. Then last digit is 6, so it will come in two tables. So here minimum 3 factors are there. So more than 2 factors are there. Nothing but a composite number. Next question. Check whether 6 power n can end with the digit 0. So here one small logic we need to remember, that is to be end with digit 0, it should have 2 and 5 as factors. So if we write the given number as a prime factors, then compulsory 2 and 5 should be there as a prime factors. Then it will end with the digit 0. Otherwise, it won't end with the digit 0. So let us check now. The given question is 6 power n, right? So 6 can be written as 2 3s are power n as usual. Now, as I said already, it should have 2 as well as 5. Compulsory 2 and 5 both should be the factors. Here 2 is there but 5 is not there. So as 5 is not a factor, 6 power n cannot end with the digit 0. 6 power n cannot end with digit 0. Check whether 7 power n can end with the digit 0. Here if you observe 7 power n, already 7 is a prime number only, so we need not to do again prime factorization for that one. Now 2 and 5 are not at all factors for this. So as 2 comma 5 are not factors, 7 power n cannot end with digit 0. Next, check whether 20 power n can end with the digit 0 or not. So here the given number is 20 power n. So here just 2 digits are there, that is the reason I am keeping whole bracket, so no need to worry about that one. Now let us do prime factorization for this number 20. 2 10s are 2 5s are. So 20 can be written as 2 square into 5 whole power n as usual. Now if we observe, here 2 is a factor as well as 5 is also a factor, as 2 comma 5 are factors. So 20 power n will end with digit 0. Next, what is the last digit of 6 power 200? So 6 power 200, if we start with natural numbers only, you need to take as the power. 6 power 1 6, 6 power 2 36, 6 power 3 216. Now if we observe all the last digits, always the last digit is 6 only. So we can say that 6 power n always end with digit 6, where n belongs to natural numbers, because I am starting from 1 onwards. So if in case if we take 0, 6 power 0 will become 1, so answer will change. That is the reason we need to start from natural numbers only. Next, how many digits will be there in the expansion of 2 power 25? So here 2 power 25 is nothing but 2 into 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 25 times. If we write like that and multiplication if we do, we will get some answer. In that answer, how many digits are there? That we need to find out. So whenever if they are asking this kind of question, compulsory they will mention the logarithm value of some particular number. So in this case, he mentioned log 2 value as 0.3010. So now if you observe the number 2 power 25, 2 power 25. Now for this, here the base is already 2 only, log 2 value only we know also. So this is already in simplified form only. Just simply apply log for this one. Log, same number as usual, again 2 power 25. Now in the logarithm, if power is there for the main number, it will come to the front as the same as it is. So 25 times log 2. 25 into log 2 value is given in the question as 0.3010. Just simply multiply these two. 25 into 0.3010. That is 7.525. Now before the decimal, which digit is there? Observe the digit, that is 7. So for that 7, add 1. So 7 plus 1 is equals to 8. So if we expand this number to power 25, in that answer, total 8 digits will be there. Next, how many digits will be there in the expansion of 4 power 76? As usual, the log 2 only is given here also. Log 2 value is 0.3010. So here the given question is 4 power 76. But we know only log 2 value. So here base is not 2. So here we need to do simplification then. So 4 we can write it as 2 square power 76 as usual. If 2 powers are there with bracket, means we need to multiply those 2 powers. So 2 power 2 into 76, 152. Now here log 2 value is given as well as base 2 we got it. So just apply log for this number now. Log 2 power 152. Now here power is for the main number, so it will go to the front as it is. Then it will become 152 into log 2. So here write 152 as it is into substitute log 2 value, that is 0.3010. Multiply these two. 152 into 0.3010. It is nothing but 45.752. Now after getting some answer like this, whatever the number is there before the decimal, for that one add 1. So 45 plus 1, 46. Next, how many digits will be there in the expansion of 9 power 147? Here the base is 9. We have the value of log 3 only. So base and the given log values both are different. So we need to do a little simplification. I am taking that number 9 power 147. Here 9 can be written as 3 square power 147 as it is. So 3 power, here 2 powers are there with brackets, so just multiply those. 147 2s are 294. So 3 power 294. Now log 3 value is given. We got base also 3 only. So now for this number, after doing simplification, what we got? For that number, let us apply logarithm. So log 3 power 294. Here the power is for the main number, so it will go to the front as it is. Then we will get 294 into log 3. So let us apply the log 3 value here. 294 into log 3 value is given in the question as 0.4771. 294 into 0.4771. So the value is equals to 140.2674. Now take the number which is before the decimal. Here before the decimal we have 140. For that 140 add plus 1. So 140 plus 1, 141. So in that expansion of the given question, we will be having 141 digits.